All right, hello and welcome back. It's your boy Hank Hackerson at Hank Hacks Hackers, and today we are continuing the security engineer pathway. We are currently on episode 10, I want to say, day 10, episode 10. The last episode we went through secure network architecture, and today we're going through Linux System Hardening, and this is all under the network and system security module inside of the security engineer pathway of TryHackMe. And the outline for today's video is this right here. So we got the intro, physical security, file system partitioning and encryption, the firewall, remote access, secure user accounts, and oops, so there we go. Our machine has started. And the outline of today's video is as such. So we got the intro, physical security, file system partitioning and encryption, firewall, remote access, securing user accounts, software and services, update and upgrade policies, audit and log configuration, and the conclusion and some final notes. And you're going to find the timestamps of all of this stuff in the description below if you want to skip around or get into a specific part in this particular room. And that's about it for that. As per usual, if you are studying for your security engineer or SOC analyst, security analyst, pen tester, ethical hacker, any of those certifications, I do encourage you to like, subscribe, and turn on that notification bell because all we talk about on this channel is cybersecurity and pen testing and ethical hacking and all that good stuff. And so everything that we talk about is actually directly applicable to your day-to-day studies as well as your day-to-day job for any of those roles. And you can use this information for your certification exams as well as what you're going to be doing when you become a security engineer, for instance. So we would love to have you as a part of the community, and I think you'll actually get a lot of value out of it. All right, without further ado, let's jump into the intro of our room here. It does require that we start the attack box because I read a little bit further in advance before I started this, so I just started the attack box because we needed a couple of minutes for it to run, and then we have a victim machine that we've already started up here as well, and it's a Linux machine, as you can already imagine. So let's first talk about the introduction of this particular room, what we're going to be doing. So Linux is obviously a very, very well-known service and platform, and it has a lot of things that would be, I guess it's called a alternative to the closed source system. And a closed source system is something like Microsoft Windows Server or Unix, which belongs to Mac and Apple. And closed source meaning, again, it's closed source versus open source being that you have things that are freely available. So you can essentially go download any version of Linux that you want from the Kali Linux website and install it on any virtual machine that you want. And they don't really have any requirements for you to pay for them or anything like that. So it's open source, right? So it cuts down licensing costs, as you can see right here, and there's a lot of great other benefits that comes with running Linux machine. But if you wanted to just compare the cost of it, the Debian 11 with the cost of hosting a web server using Microsoft Windows, if you can compare those for each of the releases, what does it say here? It's, we can't claim that Linux is always the best choice. However, the best Linux is the best choice for many scenarios. Before this option, we can always focus on securing the Linux system, also known as hardening. The term hardening is very much used in the same breath as securing something. So network hardening, system hardening, all of that is part of securing your environment and your platform and your tools and resources, stuff like that. So these are the learning objectives that we're going to be going through, which is the physical security of your machine, file system encryption, firewall configuration, remote access, softwares and services, updates and upgrades, and of course, logs. It is recommended that you go through a Linux fundamentals video or a Linux fundamentals room, or just do some Googling for Linux fundamentals. Go find yourself a cheat sheet for Linux, just to know what some of the commands that we're going to be running are, and how to navigate a Linux machine. And we also have the security principles video that is a part of the current pathway that we're on right now. So I've actually made the security principles video, and you can go find that by just searching for security principles inside of the channel content, or if you just go into the security engineer playlist that exists, that this video is also going to be a part of, you'll find the security principles video inside the playlist that we're in. This is the login information for the machine that we're going to be using SSH to log into. And they did make a note that this is actually a very insecure password. Obviously, it's probably on one of the password dictionaries that exists online too. But if we do something like this, it would be very difficult to constantly have to type it and be able to log in. So cumbersome is a good word. So what we're going to do is we're just going to end up using the username TryHackMe at the IP address that is for our victim machine right here, and then log in like that. And then we will get into the room, the machine. So that's it for our intro. Let's go into physical security here. Physical security. So you see this desk and the physical machine and how the desk is shaky. I can't tell if this person is shaking the desk or if they're trying to prevent the desk from shaking because of like a earthquake or something that's happening. It seems like it's kind of an earthquake that's happening. Okay, so in defense in depth, that's a security principle that we dealt with. There's a lot of different layers of it, and physical security would be one of them. So if you want to prevent somebody from gaining physical access to your computer, that's what you have to factor in. That's what you have to plan for. So if they get physical access to your office, it would be pretty easy to remove the disk drive, right? And then just walk away with it, or just pick up the computer and walk away with it, whatever. Or insert a physical USB drive into your machine and mess around with your machine like that. It doesn't require a lot of technical skill or like cyber ethical hacking, or not technically, I guess that's not ethical. So, pen testing or hacking experience. You just go pick up the computer and you run away with it. One of the examples that I think of is inside Zoolander, when they're like, the files are in the computer. And then he's like, it's in the computer? And then he picks up the Macintosh computer and takes it. And if you haven't seen that movie, it's pretty funny, honestly. So let's say you've taken the necessary measures to prevent intruders from taking the disk or the whole computer and running out with it, right? So you've ensured that the system passwords are complex or impossible to guess. If they can access the system physically, it's a non-sophisticated task to use grub, which is a Linux bootloader, to reset the root account password. So we have to create, I guess the adage here is boot access equals root access. So if you can reboot the Linux system, then you can reset the root password, which is a big no-no. So we need to ensure that that doesn't happen. So in the unlikely event that physical security is breached, we need to provide extra layers of protection. So basic input-output system is what BIOS stands for. UEFI firmware allows you to add a boot password, and it'll prevent unauthorized users from booting the system. So when they do this grub thing, they won't be able to reset the root password. So that's very, very important. However, this can only be used for personal systems. It won't make sense to use it on servers because somebody else needs to be able to access it. And so if you can't share that, or this requires someone to physically be present to supply the boot password. So there's a few kind of issues that would come into play if you were doing it on a server or on an enterprise machine. So what we can do is consider adding a grub password depending on the system that we want to protect. And there are a lot of tools that you can use. One of them is called the grub2 mk password, blah, 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 whatever this is. So it prompts you to input your password twice and then generates a hash for you. And the hash should be added to the configuration file depending on whatever Linux system you're in. And then this would prevent unauthorized users from resetting the root password. So it requires the user to supply a password to access advanced boot configurations via grub, including logging in with root access. And so this is the command to run. You enter your password twice, and then it creates a hash of the password. And this one in this case is a SHA-12 hash, as you can tell, or SHA-512, excuse me, which ends up being a very, very long hash, which is pretty secure. So it's important to note that adding a password for grub is not available for these systems that are deployed using cloud service providers such as our Linux machine. So we can't use that for our Linux machine. It doesn't make sense as you don't have access to the actual physical terminal. So that's a big deal. So ensuring proper physical security is a must, considering how easy it is for an attacker with physical access to wreak havoc. Adding a password to grub is a reasonable measure to block users with physical access to a system's keyboard from gaining access. So we need a plan in case an attacker finds a way to steal the disk drives. This is what we're going to probably go into in our next little task right here for file system. So first, let's answer these questions. What command can you use to create a password for the grub bootloader? And it's this thing. So grub make password yada yada yada. So let's put that in here. And then the next one is what does PBKDF2 stand for? So let's try to find the answer for this. I can probably just Google this real quick just to find that. And so there it is, password-based key derivation function 2. It's a big mouthful right there. So that is what that stands for, and let's submit it. That is indeed the answer. All we have to do is Google it. Okay, so now let's jump into the next task, which is file system partitioning and encryption. File system partitioning and encryption. So encryption makes data unreadable without the key, the decryption key. In the scenario where an adversary has complete physical access to the laptop by stealing it or your disk or whatever it is, that's where encryption comes in, right? We want to make sure that they can't use any of that stuff, so you encrypt it. And we did an entire video on cryptography as well, so you can go check that out, because I don't think we're going to do that much of a deep dive into encryption right now. So a lot of modern Linux distributions come with LUKS, the Linux Unified Key Setup, and this is what it is going to look like. So you have the PHDR, it stands for partition header, and it stores information about the UUID, universally unique identifier, the used cipher, the cipher mode, key length, and the checksum of the master key. KM stands for key material, where we have KM1, KM2, and it goes all the way to KM8. Each key material is associated with a key slot, and it can be indicated as active in the LUKS header. When the key slot is active, the associated key material section contains a copy of the master key encrypted with a user's password. So in other words, we have to use the master key that's encrypted with the first user's password and saved in KM1, then encrypted with the second user's password and in KM2, so on and so forth. Then you have the bulk data, and it refers to the data that's been encrypted by the master key, and the master key saved and encrypted by the user's password in a key material section. LUKS reuses existing block encryption implementations, and the pseudocode uses the following syntax to encrypt. And then, as you can see, it works with different ciphers. Obviously, original refers to the plain text of the data. The original length is that what is referred to as the plain text of the data length. And then you have the user supplied password that uses the encryption key, and the keys derived using the password based key derived function, which we talked about in the last task, PBKDF2. So key equals this, and then if you want to salt it, again, go check out the encryption, the cryptography video if you don't know what salting means, and so on and so forth. So using a salt with a hash function, repeating an iteration count, we also talked about this in cryptography, ensures that the resulting key is very secure, or at least secure enough that it can be decrypted by something like CrackStation or these different decryption tools. And then right here, we're already referring to the introduction to cryptography room. So to decrypt the data, then you go and you create a variable called original, and you assign decrypt as the action to it, the cipher name, cipher mode, key, encryption data, original length, so on and so forth. Most distributions let you encrypt a drive using a GUI, a graphical user interface. However, if you want to do it from the command line, these are the steps that we would have to go through. And so you install crypt setup LUKS, confirm the partition name, set up the partition for the LUKS encryption, then create a mapping to access the partition and confirm mapping details, overwrite the existing data with 0, and format the partition, mount it, and start using it like a usual partition. And in the terminal below, right here, we actually get to see a real example of this being done on a USB drive that is sitting at this partition right here in NTFS format. And so this is the series of actions, right? So you use sudo to get access to it because you need the root permission. And then once you're here, BLK ID, then crypt setup, and then crypt setup LUKS open, then the make fs extension on the drive. Strategos USB is the name of the USB specifically, and then you mount it so that you can use it. If you want to check the LUKS setting, you can issue the command crypt setup, and in the terminal we see that the UUID of the encrypted disk, as well as the cipher that's used, and the key for PBKDF2, it used SHA-256, and the salt was 194180. And with the salt for 194,000 iterations. So there was a 256 encryption, there was a salt attached to it, and it was iterated over 194,000 times to make sure that you get like a really strong key. So sudo crypt setup, and then the drive itself, the USB drive, and then we go further down, and then we can see that the salt right here was there, digested, the salt, so on and so forth. So this is for this key slot token, digest PKF2. So let's just, before going back and forth, I think this is actually all one. Yeah, because it's for this thing. So this is the header information as they implied. There's the version, the epoch, the metadata, the metadata area, and then the key slot area, the UID, label, subsystem flags, etc. And then these are the data segments and the cipher that was used in this particular case, the key slot itself, 512-bit, cipher itself, again, 512-bit, and then we had a salt attached to it. The hash type that we want to use is SHA-256, and then I want to find the part where they go through iterations right here. And so 194,000 iterations on that hash value, and it gives you a completely different hash than you originally would have started with. So question here, number one, is what does LUKS stand for? And so we have that at the very, very top one more time, which is our Linux Unified Key Setup. And that's what LUKS stands for. And we could just paste that in our text box right here. And so we can't attach external storage to the VM that we're on. So we've created one inside of our image file right here on home TryHackMe. It's encrypted with the password like this. And so to access it, you need to open it using crypt setup and then mount it to an empty directory such as my vault. So what is the flag in the secret vault? So let's go ahead and basically follow these instructions here. So I'm going to open up my terminal, and I'm going to access it using crypt setup. So we're going to go to the top right here to get access to our stuff. So we already have crypt setup installed from what I understand. So if I just do man crypt setup, I should be able to see like a manual for crypt setup. And if I do, that means I actually have crypt setup installed on my machine. And there's the manual. So we can press Q to get out of that. And so the first series of steps would be to run crypt setup and open that drive, excuse me, so that image. So sudo crypt setup yv lux format with a capital F, and then from here we need to go to the actual directory of the thing. So home TryHackMe secret vault dot image. I keep misspelling image. There we go. Let's try that and see. We're good. Are you sure that you want to do this? Ooh, do I want to rewrite this? I don't know if I want to rewrite this. Maybe that's not the right one. Oh, I need to use Lux Open because I'm using Lux format. So that's definitely not what I want to do. So you know what? No. I'm going to do no. Operation board. I almost rewrote that entire thing and then I would have to restart the whole thing. So Lux Open, I think, is the one that I want to use. And does it say right here? So to actually use the encrypt setup and then mounted such and such and such. So we're going to do Lux Open in this case because that would have been a very bad situation. So sudo crypt setup Lux Open, and then I want to do home TryHackMe secret vault dot img, and then what is after this? I guess EDC drive. Let's see maybe if that is something that I can use here. Image doesn't exist or the access is denied. Okay, well that means that I need to use the password for this. So all right, let me try a couple of troubleshooting situations here and see what we can get. Okay, so we have a command here. I could have just done this the entire time. But you know, honestly, if you use the hint like as your first thing, sometimes you don't learn as much. So, you know, that's my excuse for going through a couple of errors and then finally getting that command that they gave us. So first thing I need to do is I need to go to my home and then go into the TryHackMe portion. So I'm going to go back one, and then I'm going to do ls again, and there should be a home directory for me. And there it is. So home, and then let's do another ls. It's kind of running slow, this little machine. I wonder, do I have too many tabs open? I think I do. So let's close some of these tabs on this secondary monitor. I also have not, I'm going to leave Google open. Well, no, we'll close this one too. Why not? And let's see. That should be the only thing that's open. Yeah, that's the only thing that's open. Okay. So root Ubuntu, and it says home TryHackMe. So that, I mean, where is this thing? If it's not inside of the home folder for me, where would it be for home TryHackMe? So what if I went to, let's go to, of course, I am literally in the wrong machine, you guys. I skipped this whole freaking thing in our previous task, and I've never actually logged in to the Linux machine. I'm like, where is this thing? I can't believe it. Okay, fine. My goodness, I can't believe it. SSH TryHackMe at 10.10.213.47. There we go. And then yes, I want to continue. And password is going to be insecure pass 123. And once we are inside of that machine, then we get to continue from our plan right here and actually run the freaking command. So now what I can do is I can actually go to cd home TryHackMe, and that should work, because if it doesn't, I'll be pissed. All right, so there it is. So we got the secret vault image right there, so that works perfectly fine. And now I need to copy and paste this thing right here and run this. So there's our full command right there, sudo crypt setup open the Lux secret vault image, my vault, and then and sudo mount my vault to my vault. So let's press enter and see how that works. Enter the passphrase. So there's my passphrase prompt. And now I'm going to paste the passphrase in here and press enter. Okay, so it seems that it's been done, so there was no error or anything. So if I do an ls command, I should be able to get something in here, right? So let's see, my vault is where we want to go to. And inside of my vault, there should be the flag. Yep, there it is, lost and found. And then we also have a task 3 flag text. So that's what I want, task 3 flag text. And then we're just going to copy and paste that. And there's our flag. Can I copy this or not? Come on. All right, whatever. We'll just type it in. Cool beans. So there we go. That is it for our file system partitioning and encryption task. So let's walk into or move into the firewall task. All right, the firewall. Look at that. Our little penguin is being protected by a little shield. How nice is that? So the client server model is what we're going to revisit real quick before we can jump into a firewall. And I mean, honestly, you kind of should at the very least understand what a firewall is. But in this particular case, just to kind of do a quick review. So a client could be anything. So it could be a server, it could be a network device, or I guess, my bad. A network device could be anything. It could be a client, it could be a server, it could be both simultaneously. It could probably be IoT devices, Internet of Things devices. And the server offers a service, the client connects to the service. Examples of servers include web servers, mail servers, and SSH DNS servers, names, all of that stuff. And a client could be the phone that accesses that server through the internet, through some kind of an application or the browser, or it could be a computer that accesses the web server, right? The server listens on a TCP or UDP port that's been assigned to it, and it waits for incoming connections from the approved list of clients. The client initiates that connection to the server, and then the server responds. The firewall decides which packets can actually go into that server and which packets could leave that server. And for more information, we can go into the firewalls room, which I don't think I've even done. So that's probably going to be something, yep, that is going to be something that I will be doing in the near future. Let's see if it's inside of the learning path that we have right now. We have software security, and we have managing incidents. So firewalls is completely separate from the current path that we're on right now, which should be fine. It's perfectly fine. It's all good. We do understand a basics of it. So hopefully you just understand what I went through right now so that you can kind of put two and two together as we go forward here. Without a firewall, a client can communicate with any server without any kind of restriction, and it can function as a server and listen for incoming connections from other clients as well. In other words, if the attacker manages to exploit a vulnerability on a system without a firewall, they could use the exploit to listen on whatever port on the victim machine and connect to it without any restrictions. Setting up a firewall offers many security benefits. Rules on firewalls provide fine control, meaning fine-tuned, like a fine-tooth comb kind of a thing, over which packets can leave the system, which packets can enter the system. Firewalls rules help to mitigate a lot of security risks by controlling network traffic between devices. And firewall rules can be devised to ensure that no client can act as a server. So that's very, very important as well, because if somebody doesn't connect to your server, but they can connect to a client computer, they can use that client computer to be a server and feed back information to wherever they are in their country or in their room or whatever it is, and use your client, your computer, as a server. So you could even make it so firewalls prevent that from happening, which is very, very useful and very powerful. So an attacker can't start a reachable listening port on a target machine. The exploit can start a listening port, but the firewall will prevent all of the incoming connection attempts from happening. And a host-based firewall is software installed on a system that we want to protect. Unlike a network firewall, the host firewall restricts packets going to and coming from a single computer, a single client, a single host, single phone, right? It has two functions: who can come in, who can leave, or what can come in, what can leave. And this could be either allow or deny. That's the terminology that's used. Imposing rules on the packets entering and leaving a system will significantly improve the security posture. So let's investigate how we can achieve this on a Linux system. The first Linux firewall was a packet filtering firewall. It's called a stateless firewall, and it can inspect certain fields in IP and TCP/UDP headers to decide whether or not they want to use that packet or allow that packet, deny that packet. But it doesn't maintain information about the connection itself, the TCP connection. So as a result, the packet can manipulate a few TCP flags to appear as if it's part of an ongoing connection and evade certain firewall rules. And Linux firewalls right now are stateful firewalls, and they keep track of ongoing connections and restrict packets based on specific fields in the IP and TCP/UDP headers, based on whether the packet is part of an ongoing connection or a conversation. The IP header fields that find their way into the firewall rules are the source IP address, destination IP address, and then the TCP headers are the source TCP/UDP port and destination. So it's worth noting that it's impossible to allow and deny packets based on the process, but instead on the port number. So if you have a process assigned to a port number, for example, a web browser is used on ports 80 and 443, then you can filter those ports, because you can't filter a Google Chrome or a Microsoft Edge or Mozilla Firefox specifically, but you can filter the ports that those things use. So it's very, very important. On a Linux system, SE Linux or AppArmor can be used for more granular control over processes. We can allow the user bin Apache 2 binary to use ports 80 and 443 while preventing any other binary from doing that. And then both tools enforce the access control policies based on that, providing a more comprehensive way to secure a Linux system. So we can take a closer look at this. We have NetFilter, which is one of the, the core projects, the core firewalls that are available. It provides packet filtering for Linux kernel 2.4 and up, so any variation of 2.4 and later versions, and it hooks require a front end such as IP tables or NFT tables to be managed, and then this is what it looks like. In just one particular example, you have the SSH client trying to connect through the cloud, and then the firewall itself just prevents or allows that access to go in to the system. So we have IP tables, which is a front-end software command line tool that provides the user space to configure the packet filtering rule set using the NetFilter hooks. And for filtering traffic, you have input, output, and forwarding. as the default chains that are available on IP tables. So the input applies to the packets coming in, output applies to the packets leaving, and then the forward applies to the packets that are routed through the system and being forwarded to something else. So we want to be able to access that on our system remotely. So the SSH server, to be able to communicate with the world, we need to be able to do two things. We need to be able to do incoming packets to port 22 and accept outgoing packets from port 22. And then we translate it into the IP table command like this. So you have IP table action input, port TCP, the destination port is 22, and then accept. And then IP tables action output, port TCP, the source port 22, and then accept. So that's what it looks like to just set a basic IP tables command or IP table rule, let's call it that. And that's very simple. The action is going to be either input or output. The port is going to be TCP or UDP, and S port would be source port, D port would be destination port, and then you just send it through like that. So let's say you only want to allow traffic to the local SSH server and block everything else. In this case, you need to add 2 more rules to the set, and that's what it would be. So action IP tables action input drop, IP tables action output drop, to block all incoming and all outgoing traffic that's not allowed in these rules, right? So these are explicit rules. That's what that specifically means, is when you explicitly allow something or explicitly deny something, then everything else falls under this kind of like a holistic rule that covers everything. And all of the input is going to be dropped, all of the output is going to be dropped on port 22, with the exception of these specific actions, right? So if the rules need to be applied in a specific order in order for this to actually take place, because if you do these first, then these two won't work either. So first you do all of your allowing stuff, and then you do your blocking of everything else. You should flush or delete any rule before applying new ones, and it can be used by the -F flag, and that'll flush everything on IP tables. Now you have NFT tables. It's supported in kernel 3.13 and later, and it has some improvements over IP tables, specifically in scalability and performance. So we're going to create a very simple configuration that allows traffic to go through the SSH server. So specific, right? So the opposite of IP tables, NFT tables starts with the node tables or chains, and you need to add necessary tables and chains before adding the rules. So we first create a table, which is going to be the firewall filter in this case. So NFT add table firewall filter, and I don't think this stands for non-fungible token. All right, so don't confuse this with the NFT of Web3. So NFT add table firewall filter, and add is used to add a table. Delete can delete it. List will be able to list it, and flush is to clear it. Very similar to IP tables. And then the table and then the table name is used to specify what you want to do. So NFT add the table firewall filter. So now since we have firewall filter, we can add the input chain and the output chain for incoming and outgoing. So NFT add chain firewall filter, FW input, FW output. So far these first sections are exactly the same. Now you're doing firewall input, firewall output, and then type filter hook input priority, etc. Type filter hook output priority, etc. So the type of the filter that you want to, the type of the chain, that you want to add is a filter, and you want to do an input hook, and then this one is an output hook, and the priority is a 0, which in this case, let's see what it means right here. They haven't explained it to us. I want to say priority 0. If it's priority 0, I'm gonna guess that it's not anything to do with accept or deny or anything like that. It's just kind of granting priority, and 0 seems to be a low level priority. But this is all speculation. I would need to verify that but this is me just guessing what that means. The above two commands add two chains. So we have the FW input output, and this is of type filter and applies to the input hook, of type filter applies to the output hook. And then with the two chains created in our table, we can add the necessary rule to allow SSH traffic. And this is what we would do with that. So FW filter, same thing. So up until this part, we're not adding a chain to the FW filter. We're now just adding a filter to it. So FW filter, FW input on destination port 22 accepted, FW filter, FW output on source port 22 accepted. And then you can check the shape of this by using NFT list and then the table that we just created, which is our FW filter, and it'll show us what the rules are that we just created. So table IP FW filter, the chain for input, chain for output, and this is the hook that we created, and then the specific rule to port 22, and then another hook, and then specific ports to a specific rule to port 22. So we have UFW, which is something that is a tool that is being used to simplify things by doing a front end to the front end is what they're saying. So adding a front end to the front end to make it a little bit easier to manage. So examples would be the command line interface front end, such as what Firewall D and UFW are, and then the GUI front end, such as FW Builder. And this is our nice little graphic to kind of explain what needs to happen. So net filter has IP tables, and then IP tables has UFW, and then the command line front end, and then net filter IP tables firewall D is the command line front end. So that could be and then but you have a GUI front end, so which would be used for net filter IP tables. The FW builder would end up being the GUI front end. So it starts with net filter, you have IP tables that you're using for net filter, and then from there you can either use a GUI as your front end to the front end, or you can use a CLI, a command line interface, as your front end to the front end. UFW stands for the uncomplicated firewall. So if it's promising uncomplicated, let's see if that actually works. So if everything has been configured already and you just do UFW allow 22 TCP, it allows traffic to port 22 TCP, and that's basically all you would have to do instead of doing this whole spiel to set this whole thing up. You see how all the crap that we had to do here using the NFT tables, you literally just you have IP tables obviously, but then you have this being your front end to your front end, and you just do allow 22 TCP, and that's it. That's all you got to do. And so if you do sudo UFW status, it'll say TCP port 22 allow from anywhere, and then that would be on the IPv6 or IPv4, and this is the rule from anywhere, right? The firewall policy, before configuring it, you need to decide upon a firewall policy, and you might be the decision maker regarding the policy, or somebody else could be it, and it all basically just comes down to what you're protecting. We're not going to go into security policies, but there are two specific things. You have block everything and allow everything, and so block everything, allow certain exceptions, allow everything, block certain exceptions. So this is what this part right here is, the explicit allow or the explicit deny that we were talking about previously. So they have their advantages and disadvantages. If you have a high traffic kind of an environment, you kind of want to block everything and only allow certain exceptions. If you don't have a high traffic environment, maybe you want to allow everything and block certain exceptions. So blocking everything with a limited set of exceptions would provide tighter and better security. It might cause inconvenience. So that's kind of a big deal. So we're going to consider an example. You're responsible for configuring the host firewall installed on the university computers. In this example, the academic institution has decided to block all outgoing and incoming traffic except for DNS, HTTP, and HTTPS. So this is port 53, port 80, and port 443. In firewall terms, that you have port 53 right here, port 80, and port 443 already. This policy should allow browsing the internet over HTTP and HTTPS. However, if one of the websites uses a non-standard HTTP or HTTPS port, it'll be blocked. Dealing with these exceptions, we will create a challenge. Keeping the firewall rules organized and properly documented is tricky, and we got to try to figure out how to do it. So there's a firewall running on the Linux VM, and it's allowing port 22 TCP, as we can SSH into it, obviously. It's allowing another TCP port. What is it? So for this, we would probably end up just doing a simple nmap against this thing. Okay, so actually, I stand corrected. We could have run a very basic command that was inside our lab right here that says sudo ufd status, ufw, excuse me, sudo ufw status, and it gives us the status of our firewall. So super quick, super easy, and immediate response. And so yeah, we got a TCP port that was open. We have another TCP port, same thing, basically the v6 version of the TCP port, which is 12.526. And then this is the UDP port, which is 14.298. And that is the UDP port that's open. And so very, very quick. No other type of scan or anything that was necessary to find open ports. Usually when I see the question ask for an open port, I automatically go to, oh, I got to run an nmap scan or something like this. But just looking at the context and the content of this lab and what we're looking at, you don't need anything of the sort. You just got to run a basic command for the firewall, and then you get access to that. So very, very quick, very easy to do. So let's move on to the next one, which is remote access. All right, remote access. Providing remote access is super convenient to access your system and files when you're not around your actual machine. So it also means that you're basically providing a service that attackers will target, because in order for you to be able to do it, somebody could do a man-in-the-middle kind of an attack and, you know, sniff your password or guess your password and brute force into that remote port that you've set up for remote login, and exploit whatever the listening service is. So if it's RDP or SSH or anything like that, it basically kind of leaves some room for attackers to hack you or attack you because of the fact that you've set up a specific port to do remote access. So when you want to harden your Linux system, you got to protect against these things right here. So the first one would be to protect against password sniffing. And remote access goes through a lot of different protocols. Modern systems use SSH, which is encrypted. Older systems might use clear text protocols such as Telnet, and we talked about this in one of the videos about, you know, weak protocols or weak ports to attack, and you can go watch that. And Telnet basically, if Telnet is not secure, because there is a port for the secure conversation of Telnet, and Telnet I think is 23, port 23, SSH is port 22. If you just use Telnet, it's going to send your passwords as clear text. And so people can actually, all they have to do is just be listening on that port, and they're literally going to be able to capture your information because it comes through clear text, no hashing, no encryption, nothing. And they could just read it. And that's basically it. And this is what that that's what that looks like. So you use a Telnet client, your username and password comes through as clear text, and it goes to the Telnet server. And somewhere in the middle right here, somebody could just read this or capture the traffic and basically just see what your username and password is. And that's all they need. They don't need to do shit else. It's crucial to ensure that you select a protocol that encrypts traffic. So SSH has been around for a lot of time, and it stood the test of time because it encrypts traffic and it encrypts your username and password. So if somebody is listening, they can't really see what the actual clear text information is, and they would have to go through a lot of different steps to be able to find that information. Then there's password guessing. So protecting against password guessing, there is something called brute forcing or password spraying if there's like multiple users that they can go after. But if they're just going after one user, it's typically called brute forcing. And password guessing, if you have a weak password especially, it's fairly easy to do because there's a bunch of dictionaries that have passwords in them. It's one of the most common ones that's very popular is called the RockU password list, and it has something like 14 million passwords in it, and they're all the easy passwords. So QWERTY1234 is a very easy password, and if you put your left hand on your keyboard and you start with your pinky and you go up from so if you put your left hand on your keyboard at your home button, so your left index finger would be on the letter F, that's the home button on the left side. And so if your finger is just resting there and you go up to the upper row and your pinky goes on Q, your ring finger goes on W, your middle finger goes on E, and then your index finger goes on R, and then again T is the very next one, Y is the very next one. So it's literally just the series of keys that are on the top row of the keyboard. And then there's 1, 2, 3, 4, which is again your pinky, ring finger, middle finger, and index fingers. It's all done on your left hand basically. And it's not technically an English word or anything like that. It's very, very common in the top 10 or 20 most common passwords, because it's just one of those like easy things that you just randomly kind of do, but it's done with your left hand and it's super, super easy to do. And that just makes it one of those passwords that's very weak and easy to guess because it exists inside of these common password dictionary files. And so that's another one of those things that you gotta account for. So your SSH server is configured to listen for incoming connections, and evil users have all the time in the world to attempt one password after another, and you just need to account for that. You need to be prepared for that. So a remote login such as root needs to be disabled so that anybody who is logged in only gets to log in as a non-root user, and then disable password authentication, force public key authentication instead. So instead of them using passwords to authenticate themselves, they use a public key as a part of an asymmetric encryption algorithm where there's a private key and a public key to be able to get in. And the reasoning behind this is that you don't want the adversary to be able to attack the root account, number one, and then if it's a non-root account, you don't want the attacker to gain access if there's a weakness in the password. So those are the two things that you're trying to account for in that situation. And the configuration of OpenSSH can be controlled via the SSHD configuration file, which is located at the etc SSH directory, and you can disable the root login by just doing permit root login no. You just add that inside the SSHD config file and it removes that possibility. And this is a complex password, it's a difficult password. Most people find it inconvenient to memorize. So if the account belongs to the sudoers group, which is the root group, people that have root access, they need to be able to type that password every single time that they want to issue a command with sudo, right? Because anytime you do sudo and then a command, it asks for that password, and then you got to be able to type that. And it's difficult to memorize, difficult to type. So you can't expect this to work for everybody. Many users are tempted to select a user-friendly password, and the approach would make it easier to remember, but at the same time easier for the attacker to guess, and it would be best to just rely on public key authentication to improve the security so that you don't have to worry about those types of problems. If you haven't created a key pair, then you got to use SSH keygen and then use the RSA real secure algorithm, and it'll generate a private key saved in the ID RSA and a public key saved in idrsa.pub. And for the SSH server to authenticate using the public key instead of the password, your public key needs to be copied to the target SSH server. And then an easy way to do it would be to issue the command copy ID username at server, where the username is your username and server is the host name or the IP address that you're trying to transfer it to. And you need to just make sure that in a best case scenario and an ideal scenario, you want to be able to have access to the physical terminal before you disable the password authentication to avoid locking yourself out. And you need to ensure having the following 2 lines in the sshd config file, which is the pub key authentication is yes and password authentication being no, to disable the password authentication, and then pub key would be to enable the public key authentication. So very, very simple. So now what we got to do is we got to actually go in the sshd config file to just find the flag. So I'm going to first remote shell back into this, because I'm doing this on a second session. I didn't finish this recording yesterday, so I need to re-log in using SSH TryHackMe at 10.10.44227, and we do that, and we want to log in, and it's insecure pass 123, and that should give us access. Did I misprint that password? I think I misprinted insecure pass 123. See if that works. Okay, there you go. That worked. So now we're going to go and find the SSH config file. So let's see if we just cat it onto the screen. SSHD config, if it'll show. And let's see. Example of overriding. I think we're in the file. So let me see if I can find that flag. There it is. It's at the very, very top. So it was on the top line of the file. So we're going to copy that right there. There we go. Copy that, and there it is. So we got the SSHD config flag. And just like that, we wrapped our remote access task. So let us now go into securing user accounts. Securing user accounts. So sudo make me a cup of coffee. The root account carries tremendous power, and therefore it carries a lot of risk. You're at risk of rendering your system unbootable with a simple mistake. Using a non-root account for everyday work is recommended to avoid sabotaging your system. However, root privileges are still needed for system maintenance, installing, removing software packages, and updating configuration. So even on my machine right here, I'm the only user on this machine. And so if I want to do anything, I'm the admin, I'm logged in as the admin, the only user. But what happens is when I want to do specific commands that are sensitive commands, it says that you need root privileges or you need admin privileges. So I have to run sudo to be able to run certain commands on the computer. And when you do that, it's kind of like you go through the point of no return. Like if you do anything using sudo, you're making real changes that could potentially harm the system, right, or sabotage the system. So to avoid logging in as root, the better approach would be to have an account that's created for admin purposes, added to the sudoers group, who can use the sudo command, which stands for super user do, and it should precede any command that requires root privileges. So you can create a user, add them to the sudoers group, and then they can use the sudo command, but it won't be the actual root user doing it, right? So that's very important. Depending on the Linux distribution, we can add a user to the sudoers group in the following ways, such Debian and Ubuntu call the sudoers group sudo, and you would need to issue this command. So user mod add g, so add to group sudo the username. So user mod is modifies a user account, so user modification, append to group. The group name is sudo, so we're appending to the group sudo, and then we're going to append whatever the username is to that group. So user mod ag wheel username. Wheel is the same thing for sudo. It basically is the sudoers group, but it's in the distribution of Red Hat and Fedora. That's the name of the group, and so you would do it pretty much the same way. User mod ag wheel, which is the name of the group for sudoers, and then the username. Disabling root. So once you've created the account and added it to either sudo or the wheel group, then you got to consider to disabling the root account. and you just go to etc password and change the root shell to sbin no login, which basically means edit the etc password file and add this right here to, or change the original line right here to this. So we can just go check this out in the shell that we're in right here. So if I go to cat and I do the etc password file, we'll be able to see this, and then we just scroll to the very, very top of this file and we'll see that the first line is our root user. And let's go and make sure that we actually are there. So that's the first line. So the first line is the root user, and you see how it reads bin bash right here. This also reads bin bash, which means that that's the actual bash binary that's being used for this. So to disable it, you just want to change that to this thing, sbin no login. So that way it's not able to use the bash binary and it just gets disabled. So very, very simple way to do it, and it's quite effective. Then you enforce a strong password policy. This is the library password quality that allows a lot of options for password constraints, and it can be found in the security security. I am drawing a blank for directory. That's the word. I'm like, how did I forget the word directory? So it can be found inside the etc security directory or etc pamd, and then you can just do apt get install the library to just make sure that you actually have it. But depending on which kind of distribution you're using, this is where it would be located. And then so DIFOK, so defoc, whatever, allows you to specify the number of characters in a new password that were not present in the old password. Minimum length, minimum allowed length for passwords. Minimum class is the minimum number of required classes of characters, and a class could be uppercase, lowercase, digits, among others. Bad words, which is a space-separated list of words that must not be contained in the chosen password, and then retry and prompts the user a number of times before returning an error. So this is an example of a password policy right here. So 5 would be the specified number of characters in the new password that were not present in the old password. So when you create a new password, you need to have at least 5 new characters in that new password that were not in your old password. It just kind of ensures that you don't reuse your old passwords, basically. Minimum length is that it needs to be 10 characters long. Minimum class, it needs to be 3 different types. So it could be capital, lowercase, and numeric, could be the 3 different classes. And then you get 2 retries. And apart from that, you get an error that you can't do it anymore. So you can check all the available options through the manual for that configuration file, and then disabling unused accounts. And this is also a big deal because that's another one of those attractive places for hackers and attackers to go to, where they look at unused accounts and they just assign themselves to those unused accounts. So it's very important to disable user accounts that no longer need access to the system. The user might have moved to another department or quit the company, so you just want those things to be gone as soon as they're gone or as soon as they change departments. Disable a user account in the same way that you would disable the root account. It would be to edit the etc password file and then set the shell of the user account to be this, or you could just delete them. Enable account Michael such and such and such, disabled account Michael, and then same thing. The user bin fish turns into sbin no login. So that's like a really basic way of disabling them. You can also do it for local services. So we can set the shell to sbin no login for all the local services, such as www.data and Mongo and Nginx. And the reason is that these services need accounts to run the system, but would never need to log in and access a shell. So that's very important. So they need to run a system or run some kind of a service, but they don't need to actually access a shell. And sometimes they're set up to do so by default. So you just got to disable them and remove those options. And any of these things could have a remote code execution vulnerability. We've done the www.data on web servers a lot when we're like using web shells to get into a web server. This is one of the vulnerabilities that we use a lot. Nginx, same thing. So you set the shell to no login and then prevent interactive logins for the account of that affected service. So the questions for this task are as follows. One way to disable an account is to edit the password file and change the account shell. What is the suggested value to use for that? Which would be, I think it's sbin no login, right? Yeah. What is the name of the Red Hat and Fedora systems sudoers group? Wheel, right? Yeah. And what is the name of the sudoers group on Debian? That would be sudo. And other than TryHackMe and Ubuntu, what is the username that belongs to the sudoers group? So let's check who belongs to the sudoers group. And we're here already. And I wonder if it tells us what group these people belong to. There is a way that I can check who belongs to the sudoers group. So first, let's see if any of these commands right here we could use. Okay, let me check real quick. Maybe the hint will tell us. Oh, okay, so the etc group file. So let's go and check that. I misspelled cat etc group. All right, here we go. So we're looking for that belongs to the sudoers group. So all right, found a quick little hack here to make it a little bit easier. So we grepped for the word sudo, and then we grepped it inside of the etc group file, which is the one that we had right here to list. And then we cut the part of the file that shows the actual username that has that sudo in it. So we have Ubuntu, TryHackMe, and Blacksmith. So this is a very useful little command that I just found by doing a little bit of a Google. And there it is. So Blacksmith is going to be our user. There it is. Nice. Nice. All right, so we are good with this one. So let us now go to software and services. All right, so we gotta disable unnecessary services. And we talked about this a little bit in the last task. So the easiest ways to improve security is by just removing and disabling services and packages that aren't being used or they're not necessary for the business practices. We need to minimize the number of installed system packages is a simple way to say it. Every package carries risks because of the way that they're set up, and it could be third-party packages that you can't guarantee that they're secure, so on and so forth. So very, very simple is if you just know that something doesn't need to be installed on a computer or on a machine, just uninstall it or disable it. If you don't need a web server, then don't install one. And if there's one installed as you virtualize your machine, because a lot of times when you virtualize something or when you install an operating system, there's a lot of pre-installed softwares and services that are on there. So if you don't need it, just uninstall it or disable it. If you needed to run a web server at one point but no longer need it, again, remove it or disable it. So it's very, very simple to think about. Block unneeded network ports. So if you don't use certain ports or you don't need them, block them. Explicitly block them. After you remove a package that's not required and disable pre-installed services, then it's critical to set the firewall rule accordingly. And if you don't have a web server, there is no reason to allow packets on port 80 and 443 to go through. So block those ports. Reasoning is that the attacker manages to start a disabled service. The firewall will block the traffic and the attacker won't be able to access it. Avoid legacy protocols, and legacy protocols are those things that have kind of been grandfathered in, and they're in there because they used to be on old distributions and now they're just there, right? So Telnet was a primary protocol to access a system remotely, and it's a legacy protocol. It's kind of old school, as you want to call it. So the TFTP protocol was commonly used to transfer files. So these protocols are no longer allowed as secure alternatives. If that's the case, block them, right? Instead of Telnet, SSH is what's used. Secure File Transfer Protocol, SFTP, replaces TFTP, which stands for Trivial File Transfer Protocol. So it's very, very simple, right? It's very common sense and basic, but if you just don't use them, and to even make it better yet, you just block those ports and those protocols, then you're golden. And then remove identification strings. When you connect to a remote server, it usually replies with a version number. And when somebody has the version number, they can start searching for vulnerabilities and exploits for that version. So if you can do that, if you can remove the identification string of that, then you are also protecting yourself in a manner that they can't research your distribution to try to find any vulnerabilities or exploits or anything like that for it. So removing an identification string seems, again, very simplistic, but it's very, very effective. So the question here is, besides FTPS, what is another secure replacement for TFTP and FTP? And I think is SFTP. Is that it? Yeah, SFTP, Secure File Transfer Protocol. So there is our very quick software and services task. So let's go into update and upgrade policies. This is another one of those kind of commonsensical types of things where the latest security updates and patches and bug fixes, you just got to make sure you update your system and upgrade them regularly. As soon as something comes out that can update and upgrade your software, your system, anything like that, you got to do it. A Debian-based distribution such as Ubuntu, you can just do apt update to download package information, apt upgrade to install available upgrades. On Red Hat or Fedora, this would be your command to update and upgrade those things. And it's just good practice to do that regularly. Microsoft is obviously pretty good with this kind of stuff because they give you notifications in advance or anytime anything new comes out. But for Linux, because it's an open source operating system, I don't know if they have developed them by the time, after this room came out, because this room is probably fairly old. Let's see, it says it's 313 days old, so it's almost a year old, this particular room. So we don't know how frequently these things get updated and changed. So just as a good practice, if you're running Linux, you just want to make sure that you update and upgrade your system regularly. The LTS releases, the long-term support releases, are released every 2 years, and they have an even version number. So 04 for April, 1804, 2004, 2204, etc. And LTS version will grant 5 years of security updates for each base without a subscription, and another 5 years if you pay for extended security. More information is available on the Ubuntu Lifecycle release cadence. And using an Ubuntu LTS release, you can download updates without a subscription for the first 5 years. And consider Ubuntu 14.04. It was released in 2014 on April, right? Its free support ended in 19.04. In other words, free update services will be available until 2019. In the terminal below, we see that there are 133 additional updates that we can download and install if we have Ubuntu Pro, and previously known as Ubuntu Advantage. So when you run uname A, it'll say where. So this is the current version that exists right here. And then sudo apt upgrade, it gives you all these things. And then 133 additional updates are available with the infrastructure. So 14.04 was released more than 5 years ago, hence free upgrades are no longer available. From the security point of view, the user should either get an Ubuntu Pro subscription or switch to a new LTS release, such as 22.04, so that they can get another 5 years of free security upgrades. So when you run a system that doesn't receive security updates, it exposes your system to be attacked. And so when you're the attacker and thinking about it, you can just consider, hey, you know what, if I search for something that is Ubuntu 14.04, it's probably likely that, if they haven't bought the Pro version, it might be likely that there's still vulnerabilities that are available and there haven't been patches and updates, so on and so forth. So it's always good to know the both sides of the whole thing. Then you have your Red Hat releases. Enterprise Linux 8 and 9, they have 12 years of support in 3 phases. So full support for 5 years, maintenance support for 5 years, and extended life phase for 2 years. So Linux 9 was released in May 18 of 2022. So full support is available until 2027, maintenance support until 2032, and that's, I mean, it's pretty damn good. Kernel updates. Updating this system should not be limited to the installed software. It should consider updating the kernel. So in 2016, a security vulnerability that affects Linux kernel was discovered and allows the attacker to gain root access by exploiting a race condition in the copy on write mechanism, cow mechanism, and that's where the dirty cow came from. Vulnerability is present in all Linux kernel versions from 2.6.22 and onwards, and it's been patched in most distributions, but it's still a threat to systems that have not been updated. So it's a severe vulnerability that allows attackers to gain root access to Linux systems, and it's crucial to keep the system, including the kernel, up to date to the latest security patches to just reduce exploitation. So automatic updates. Now that you have a Linux system with security updates through the lifecycle, we got to ensure that they're all properly installed and security fixes are applied, and you just got to stay updated. And depending on the distribution that you're using, you got to configure automatic updates if you can, which is always a good move, and it can save you a lot of headache and save time, so on and so forth. So what command would you use to update an older Red Hat system? And that is up here, so right here. So DNF update or yum update, and it says Linux 8 or 7 and older. So let's see which one they're asking us for. It doesn't say which one, so let's see DNF update maybe. Nope, so yum update, that's the one. What command will you use to update a modern Fedora system? And that one I think is just apt update, yeah. So apt update is that one. Okay. Upgrade. Okay, so maybe DNF upgrade? Is that what it was? Yeah, DNF upgrade. Okay. What 2 commands are required to update a Debian system connected to commands with and? Okay, very good. So we're updating a Debian system. So it's apt update and apt upgrade. There we go. What does yum stand for? That is a good question. So let's Google that. So what does yum stand for? What does yum stand for Linux upgrade? Let's see. Yellow Dog Updater Modified is what yum stands for. I would have never guessed that shit in my life. There we go. Submit that. And then what does DNF stand for? So let's do that now. Let's just go up here and just change this to DNF, and then dandified yum. Dandified yum is what that stands for. And what is the flag hidden in our sources.list file? So let's see if we can even find that. So we're going to run a very basic find command, and this is why you need to know basic Linux. So find name sources.list, and then we want to do to dev null to go through any, to avoid any errors basically. And so it immediately popped up, which is usually very, very good. And we have several here. So I want to say it's probably the etc apt one. So we're going to do cat etc apt sources.list. And let's see if we can find a flag in here. Yep, it's right there. And we're just going to copy this. And that is our flag. Cool beans. So let's move on to our last piece here. So audit and log configuration. Most of the logs in Linux are inside the log directory. And when you're looking into threats, these are a lot of the logs that you gotta kind of keep track of. And the important ones are, of course, the security log or the secure log, your kernel log, the boot logs. I mean, these are all important. That's why they're probably been listed here. But there's a lot of logs. And these are the things that you just gotta audit. So that's the thing, right? Like uh, they 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 log. I mean, each log logs the activity inside the computer and the things that have happened, and a lot, authentication logs store authentication information, meaning usernames and passwords. So it's very, very important to audit your logs and you just make sure that those things are all secure. There are two handy commands for large log files. New events are appended to the log file. You can view the last few lines using the tail. So for example, tail N12, which is the last 12 lines of the boot log file, and then search them using grep. So grep failed on the boot log file will look for failed login attempts. And that's also just very, very important, right? You have to be logged in as a root to precede your commands with sudo. So as long as you have access to the sudoers file or the sudoers group to see what's going on. So what command can you use to display the last 15 lines of the kernel log? So tail n15 and then kern.log, and that's our command. And what can you use to display the lines containing the word denied in the file that is secure? So we're going to do grep denied and then secure.log, just like that, right? Or secure. Okay, so not a log file, but secure file. And that's it, just like that. Very, very simple and easy to harden and secure your Linux machines. And let's see what our conclusion says. Conclusion doesn't really say anything here. It just gives us an overview of what we went through inside of this room. So hopefully that was actually useful to you. If you are studying for your security engineer or cybersecurity analyst or Pentest Plus or ethical hacker, any of those certifications, I encourage you to like and subscribe and turn on the notification bell and join our community, because all we talk about on this channel is cybersecurity, security engineering, pen testing, ethical hacking, all that good stuff. So you'll get a lot of value out of it. It'll actually be helpful to you on your certification exams and on your day-to-day task as a security analyst or an engineer, for example. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker. I hope you got value from this video. Love, peace, and chicken grease. If no one else loves you, Hank loves you. And I will see you in our next episode. Later.